Okay, in this video, we want to continue with asynchronous JavaScript, and we're going to start talking about JavaScript callbacks. Okay, so in the last episode, we discussed the infamous event loop. All right, the idea here is we have JavaScript that runs, and it usually runs according to a certain event that takes place on your website. All right, so everything is event based. So when the user clicks a button, there is some code that should execute. And so that event goes into the event queue, and there can be multiple events that stack up, pile up here in the event queue. And when we get to this point in the event loop, we pull one of these elements off. The task is the synchronous JavaScript that starts executing synchronously. Okay, so we have one thread that is responsible for executing our JavaScript and going through this entire event loop, including rendering the elements. Okay, and so we don't want to block this thread with a long bunch of synchronous JavaScripts, because then website elements won't render properly in real time as the user hovers over an element or clicks an element or anything like that. So we want to keep this free to repeatedly render as needed. And so the way we do that, since JavaScript is single-threaded, we use the idea of asynchrony, okay, and events. So JavaScript is event-based. So we have an event, comes off the queue, the task runs synchronously. When it's finished, it goes off. We grab the next item in the queue. Same thing. When this is finished, now we go to any timeouts, and we check to see if there are any timeouts that have expired. If so, we grab those, take off the task, run the task synchronously, come back, and then we can render the DOM, update the DOM with any effects, like a mouse over event might change the color of a button, or a click might change the CSS on that button, and then we check for more events to add into the queue. Okay, so JavaScript, you'll hear all the time, is single-threaded. That's true. Your JavaScript is single-threaded, but the browser and even Node.js have more than just that one thread. They have a separate thread that can do certain things like manage the event queue. Okay, but all of your code is going to be single-threaded. The event loop on a browser is a different event loop than something like Node.js, though they behave similarly. Okay, but it is important to know that they are not the exact same software. It's not the exact same code that runs the event loop, because, for example, the browser has this render section that Node.js doesn't need to do, but Node.js has something else where it has to check for events from the operating system. Like if you're opening a file and reading something from a file, you need to know when the file is available. When you write something to a file, you need to know when it's been written, right? So those are the types of events Node.js has compared to the browser that has these kind of DOM render events. All right. So that's what we talked about last time, and how that applies this time is we've got this concept of callbacks. All right. So a callback is basically you are running some code. We've got some code here that we're simulating. This is basically a back-end web service. This would be our database. We're just going to be simulating a database with a memory store. What we mean by that is it's just something in memory to store data. Okay, so we're not storing this to a file or a database or anything like that. Now we could just use a user's object and have an empty object and add items to that object. That's a very common thing to do in JavaScript. You see it all the time. However, there's newer features of JavaScript that are much better. Using a map is a much more efficient data structure to use for something like this. Anything that's going to be like a key value store, like a dictionary in Python, you probably want to use a map. Objects are more for you set up the object and it has certain properties on it and you don't modify them a whole lot. Okay, if you're going to specifically, like something like this, we have a user's object that we plan on setting and removing users from all the time. That's perfect for a map. It's a much more efficient data algorithm for that sort of data. Okay, so these are just maps. So it's much more efficient, and the way you create this is you create a new map, and then this is your key. So you use the map.set, and then you have some object. Okay, so this is pretty standard for some sort of back-end system. We're not using all of the best practices here because we're just trying to do a demo of asynchronous JavaScript. But you would have a user ID, a username, a password. Of course, you would never want to store a password in plain text. We would want that to be a password hash, and we'll get to that. Then you have some other email, other information like email. You might have an is logged in property. It's maybe not the best way to handle something like this, but again, it's a demo. And then your user preferences, right? They might use the dark mode of the website or the light mode or something that they have staved that relates to your website, right? And you might have a lot of different preferences here. And then additionally, you might have some sort of shopping cart. So pretty standard type of, back-end, simple data structure for a user, okay? And what we want to do is we want this async function to get some information from the server. All right, so we're going to simulate that with a set timeout. Okay, so this is not technically an asynchronous event type of function. If we were to actually call the backend service and use the fetch API to call a backend service, it would be an event, but we're going to emulate that with timeouts because timeouts also have this timeout queue and this synchronous behavior. So it kind of acts very similarly. All right, so we're going to emulate asynchronous functions using timeouts, and then what we do is we want to log in a user down here, right? So we've got this user Bob, right? And then Bob's bad password. And we pass those two things in and we get the user, and then we say that user's logged in and we log that user. And then we want to return that user because we want to do something else with that user, right? We want to maybe add something to the shopping cart, okay? So see if you can find the problem here. We have a set timeout. I'm returning the user, right? And so I've got user here. I guess I might need let or something. And let user equal user login, and I'm going to log user. So hopefully you can see what the problem would be right away is the function that actually returns user is here, and that's not set to anything. So the value that's returned from this doesn't go anywhere, right? It just, this function, when it's executed, it evaluates to that user. That's not stored anywhere, so JavaScript just moves on, right? So the problem is this is going to be undefined. All right, so let's see if we can run this. Now notice, undefined showed up first, and then we got the console.log, right? And that's because that's actually to be expected, right? We have a timeout of 2 seconds. So this is synchronous code that executes user login. This function doesn't return any value, right? We could return a value, but it would be down here, right? It's not going to be inside of here, inside of the timeout, right? So we get foo back. All right, so this is problematic because it's very common with asynchronous programming to want to do one asynchronous thing, and if that completes, do another asynchronous thing, and if that completes, do another asynchronous thing, right? So you want to kind of chain these asynchronous tasks together. This is absolutely critical to everything JavaScript. Asynchronous programming is absolutely everywhere in JavaScript, and there are different ways to handle it. So one of the first ways people have come up with handling it is sort of this callback idea, and it relates to the browser model. Like whenever you have a click event on a button, for example, there's basically a callback associated with that. They don't technically call that a callback, but it's the function or the JavaScript that is executed when you click the button, right? It's essentially the task. It's some code that's associated with this event, okay? So if this thing happens, run this code. So that's kind of, we think of this as our callback, right? So if this thing happens, take it off the event and then run the code. That's how the browser event loop works. So what does that mean in this context? Well, if we're fetching something from a back-end service, we don't know how long it'll take. There could be a lot of network hops. So this could be almost immediate, or it could get hung up and maybe take 10 seconds. It might time out and we might have to resend the request, right? So because we don't know that, we can't write synchronous code to get the user and then just do the next thing and do the next thing and do the next thing, right? Because we don't know how long it will take. And also we have to keep, in JavaScript, we have to keep this event loop going. Otherwise we lose functionality in the website for rendering other interactions, right? So that's the whole point of asynchronous programming, is to keep other things, other interactions with the website or JavaScript, like it might be interactions with the operating system in the example of Node.js, but keep the event loop open so we can still interact as much as we need to. And things might pile up on the event queue, but that's cool. They'll eventually be processed, and then we keep going through this event loop. All right. So how do we fix this? What's a way to fix this? We can have what's called a callback. So here's the callback. And basically, this is the thing that we want to do after we get the user data. So here's where I am. This is actually in the database, right? So this is the backend function, right? We're calling, or we'll say backend. And we want to get this user from the backend and then do something with it. I can't do it like this, right? So what I can do is I can define a function that is a callback. All right, and I've got one already created here, so you don't have to watch me. So we make this handle success login, right? This is the callback. So this is what we run if we successfully are able to get a user. Okay, so this is our callback function, right? These are the arguments when we're calling the user login function. These are the parameters. So parameters are like variable names. The arguments get stored in the parameters. All right. So when we call this callback here, so this is our success callback. It's this function. It's whatever we provide. And in this case, what we want to do is instead of returning the user, we'll say callback user. So what this allows us to do is have asynchronous access to this user object. Okay, and if I have, that's going to become this item here. All right, so our callback. So this gets a little confusing because JavaScript uses functions as first-class citizens, right? And that's really important. That's used everywhere in JavaScript. So you kind of need to get used to the idea of passing a function to another function, right? And then this function is called, and we're passing in the data that we got here. And so now we can handle a successful login and actually have access to that data. All right, so that's what this is. Let's take a look at that. Let's run this again. Okay, so we see the backend finally succeeded, and then this, the login success callback, that's our handle login success, and that's fine. All of this is great, but what if there's one other issue? What if we have an error, right? So what if we pass in, the username Alice? Okay, so now we've got an issue. Cannot set properties of undefined, is logged in. Okay, so we've got some errors that we need to account for, right? Because you're never going to write perfect code. So how do we deal with this? We could do a try catch, and then let's see what happens when we try this. All right. I need my curly brace. All right. Okay, why didn't it catch? Right? It's the same problem, right? Try is a synchronous code block. We want to catch this error, but our set timeout function ran successfully. All we did here was call set timeout. That function ran. This function did not run. This happens later on the event queue, right? So we successfully called that, and then we're going through the event loop, and this is our timeout is what had the error. So now it's difficult because I need to get that error information from the timeout back. So it's basically the same problem, except we need an error callback, right? So we need a success callback and an error callback. And this is really common in Node.js. It's one of the standard ways of working with asynchronous, like file system access, all sorts of different things, right? Now they have advanced quite a bit, and there are different APIs now, other than callbacks. But callbacks was kind of one of the first ones when Node.js first came out, right? And it's still available. It's used a lot. All right, so we have this error callbacks parameter, and so what we need to do is add an error handler, right? So we've got handle login success and handle login error. Okay, and then we just pass in our handle login error function. All right, so we know this try catch doesn't work, so we can go ahead and get rid of that. And we're handling the errors with the callbacks. Okay, so this should give us an error, right? Because we've got Alice instead of Bob. All right, and it does give us the error, but we didn't check for the error here. We never called the error callback, right? So we've got this error callback in here, but our function is just getting an error because there is no error or Alice user. Okay, so what we can do is let me add some code here, and we're going to try and catch inside of this, and we'll see if this kind of makes sense here. Okay, we're going to start with our user. We're going to see we want to check for the user password. I'm going to go back to password hash here in a second. We're gonna do that next. All right, so we've got a username and a password. We've got an error, a callback, and an error callback, right? And so what we want to do is try to do these things. So if users.has is a method of the map, and it checks to see if that item is there. If that exists, if it does not exist, we're going to throw a new error. It's like raising an exception, okay? But we're doing all of this in a try block, and so eventually any errors that we throw here in this try block, we're going to catch the error. And if we have one of these defined, so if the user actually passes in an error callback, because they might not, so if error callback exists and equals function, we're going to call that error callback and pass in the actual error that occurred. Okay? So the abstraction here is pretty clever, right? So we're going to, since this is asynchronous, we can't work directly with return values, so we have functions and we pass those values in there. Same thing for errors. We can't work directly with errors, so we have an error callback and we pass any errors that occur into the error callback, right? So here is the success case. Users exists in our database here, our memory store. We get that user. If the password, user.password does not equal the password provided, we say invalid password. And I'm going to change this to a hash in a second. And then we say the user is logged in, right? If all of this succeeds in the try, then we skip over the catch and we say if there's a callback provided, which there might not be, but there's most of the time there will be, callback, and then the return value we want here is the user. All right, so this is basically the exact same method we had before, except we've added error handling. We're checking for errors. All right, one important thing here is if we do catch, we want to make sure we return, because we don't want to do this part. We don't want to also call the callback. Okay, so that's something we don't have to worry about when we're throwing errors usually. If we're not catching them, if you throw an error, you don't have to worry about returning from the function. But in this case, because we're catching it and you calling an error callback, we do have to worry about returning from that function. Otherwise, this will get executed. And so then both the error callback and the callback would be executed. We don't want that. We just want one or the other. All right, so let's see how this works. We've got Alice, Bob's bad password, handle success, and handle error. Let's run it again. Okay, no response, user login, error callback. Oh, error callback. That's why we got no response, because that didn't exist. Okay, login error callback. So we do indeed get to this section, login error callback, right? That's our error callback. And then we are just logging that error. So console.error to the terminal screen. Now, the reason I'm using console.error is in various settings, it prints out differently. For example, in the browser, if you do console.error, it prints out in a different way, and it specifically goes to standard error as well in the terminal. Okay, so we've got one error. We want to see if our other versions work. What happens if we do Bob? So this should work, right? Bob's bad password. That's the correct password. Okay, and login success. So we get the user. So now we have error handling, and we actually have valid information, right? So that's pretty cool. What about if we change the password? So this should be a bad password, so we should get a different error message. Login error callback, invalid password, right? Provided for Bob. Okay, of course you wouldn't ever want to log out password information. This is just an example. All right, so that's pretty good start. But now we want to do something else. We want to do an additional type of thing because we want to make sure Bob is logged in, and if Bob's logged in, then we want to add something to a cart, for example. Okay, so let's try to do something with that. Let's add an additional async function here, and what we want to do is to make this work. Because we don't know what the times will be, right? I've got 2 seconds here for login, but really the real issue is we don't know what it will take, right? Whenever the event occurs that it's completed, that's when it occurs, right? So we don't know that for sure. But in order to make this work out properly, I'm going to make the second call take less time than the first call. And we're going to see this would be the error case because we want to add something to cart only if our user is logged in, okay? Actually, let's before we do this, let's fix up the password hash thing. All right, so if I want to make a password hash, you never want to store passwords in plain text. It's a horrible system. Lots of professional places do it, and it's the worst. Do not do that ever. If anybody tells you you should do that, tell them they're wrong. All right, so what we want to do is we want to hash the password. What is a password hash? It basically takes any string, and there is a library called Crypto, and it cryptographically provides different hashing algorithms. Okay, so the best way to look at this is maybe in Node interactively. So we're going to, let's go Node. We're going to import Crypto. I'm in interactive mode. It likes CommonJS, so I have to say const crypto equals require crypto. Okay, so this is why you need to know the different module types because you run into it all the time. So we've got crypto here, and what we want to do is we want to you can search to see what crypto hashes are available with crypto.getHashes, and this shows all of the different crypto hash algorithms that are available. We're going to use a really short one that's not very secure, but it also makes it's more readable for little toy programs like this, right? You wouldn't want to use SHA-1 for this. You'd want something much more secure, but we're going to demonstrate what that does. So this is the crypto algorithm we want to use, and we want to say crypto.createHash using the SHA-1 algorithm, right? So crypto.createHash using SHA-1. Is it hyphenated? No. Okay. And then update. And we want to add some string in here. Update. And what the hashing algorithm does is it converts any string to a fixed length string, a randomized, seemingly randomized fixed length string, right? So I can have the word cat in here, and then I can create the digest. So that's basically running the algorithm, and the digest produces some sort of binary result, and I can display that binary result in a different form if I want. So it's a binary ones and zeros, but I can display it in a hex output, for example. Okay, so this is what the word cat looks like if you run the SHA hash algorithm on it and a digest of hex. Okay, and anytime I do that, it's always going to be the same hash digest. No matter what system I'm using, as long as I'm using the SHA-1 algorithm, it's always going to give the same value. And what happens when I have a really long, series of characters, right? You can have as many characters as you want in here, and it still is a fixed length, right? So the problem with this is the idea with the hash is you want to kind of randomize what you're storing. So if this is a password, we don't want the user to know what the actual password is. Let's say your system gets hacked and people have access to your user database. You don't want people to know that a particular user has a particular password, because even though people shouldn't use the same password for different sites, they do, and that's a very common way of hacking other people's sites. If you use the same password on multiple sites, if one site gets hacked, they'll use the same email and same password on your email account and all the other accounts that you have. And if any of them are the same, they'll find it, right? So we put somebody's password in here, all right, and we get a hash instead. Now they don't know what the actual password is. So that's good. So this is just standard, back-end practices. You want to make sure that you hash the password. Okay, so that's what I'm doing here. But what is this salt? Okay, generally speaking, you want to have your application to salt the password, right? So the salt is some extra information as well that's added to the user's password. So the user doesn't necessarily know this. If it's in our web application, they might. But the point of this is, if you add the salt to the password, then people can't do, like say somebody hacks the database, they can't just run a bunch of hashes on random words, like my hash here was password, right? If they run a bunch of cryptographic hashes on password, they might recognize a hash because this is a bad password. It's a dictionary word, right? That's why you're not supposed to use those. They might recognize one of the hashes in the database and then know your password. So if you add this salt, the idea is the attacker would have to both know that salt and then also know where to add it at the end or the beginning, and then do the algorithm. Okay, so it's just an extra layer of protection. It's pretty standard in the cryptographic world. All right, so I just wanted to touch on that. So we have a hash password. The salt can be whatever you want, right? So I've got George Orwell 1984, whatever you want to add in there, but add that to the password and then create the hash, update, and digest. All right, so now we're returning a password hash. So we want to make sure when we call this backend service function, we want to go ahead and call our hash password. So now we're passing in not the password, but the password hash. And then we want to make sure password hash is here. Password hash. Password hash. And then up here we need to change this to password hash. Okay, the other thing we need to do is actually save the hash of the password instead. So what is Bob's password? Bob's password was Bob's bad password. Okay, so we get this hash, and this is what we can store in our hash password. All right, so we've got that, and we're hashing the password. So let's just see if everything works after changing the hash password. Okay, invalid password. Okay, Bob's bad password. What did I do? Bob's bad password. password. So it's saying show on. Oh, it's because of the salt, right? I didn't have the salt before. Yeah, all right. So it didn't match because I had the salt. So this is the actual hash that we need because we've got the salt in there now. Okay, so then we can do this. Paste that in there. Now this should be correct. Okay, did I save? Control copy. Oh, I left out a character. Yep, all right. Now maybe this time. All right, so we did successfully log in. You obviously, when you're returning something from the backend system, you probably wouldn't return the password hash, right? You don't want to be sending sensitive information back and forth if you don't have to. But we get a user ID and all this other stuff we say is logged in. We could pass in the user ID from here on out instead of the username or any number of different things, right? But so we have this Bob data, right, that we're getting back, but we want to do something with it. So we want to say we got the shopping cart. Let's say we have in our memory store up here, we also have a table of items that we can have for purchase. Okay, so let items, and this is a list of different things. And what we want to do is basically we want to log in with Bob, but we want to add an item to our cart. Okay. And so let's add this function in here. We'll go over it briefly. It's the same setup, right? There's some boilerplate here. We have add to cart. We're going to pass in a username. You could do a user ID. It depends on how your system's set up, right? The item that you want to add. And then we have callback and error callback, right? Same exact setup as this, very common pattern. We're going to want to return the user just so that they can verify that the shopping item was indeed added to the user. So we do the same stuff. We define the user. If we don't have the user in our database, quote unquote, we throw an error, right? If the item provided does not exist in our list of items, right? We defined our list of items here, gizmo, trinket, doodad, widget. If that doesn't exist in our list of items, then we throw the error here. And then we try to get the user. And if the user is not logged in, then we say, user's not logged in, we can't add the item. Okay, so this is a way of making it so we don't always have to be passing a password back and forth, right? We don't want to constantly have to send the password with every request. The system knows that the user's logged in, and obviously this is not secure. There are other ways of handling that, but we'd normally send like a session cookie to the browser, and that session cookie would only last for a certain amount of time, and we'd use that session cookie to validate or authenticate the user for every request, like adding something to a cart that requires authorization, right? So so we're kind of, this is not good practice, but it's just a demonstration of callbacks. Okay, so we've got new error, username is not logged in. Okay, if all of this works and we don't have to throw any of these errors, then we're gonna push an item to the shopping cart. All right, if we do get an error, do we have an error callback? If so, call it and pass in the error, then return. If we didn't have the error, then and we've got a callback, then we're just going to return our callback data. All right, pretty much the same idea as this. So it's a pretty standard pattern. Now the difference again is this one takes 1 second, asynchronous. This one takes 2 seconds, asynchronous. All right, so let's do this. User login, Bob. Let's say we have we need handle success and handle error for the add item. So we're going to handle add success and then handle add error. So we've got Bob logging in correctly. Let's try a couple of these things. Okay. First, let's just try it correct. Okay. So we want to log in as a user. Now we have to be logged in order for this to work, right? Now the login process, though, we know takes 2 seconds, and this process takes 1 second. All right. So this is going to be problematic. Oops. All All right, let's run this. Okay, we get an error. Item gadget does not exist. But then, do we have gadgets in here? We don't. Let's do a gizmo. All right, so we know that error works. That's nice. Let's do a gizmo. And gizmos should be in our list. Okay, so let's see what happens. Okay, Bob is not logged in. Okay, but here it says is logged in. The problem is this asynchronously occurred after this request went through, and that's possible in a networking environment, right? You can send a packet of information, it can go across the network, and it might just be slower than the packet you sent before it, or so that's a possibility, right? So is logged in, we basically need this function call to only be called after we get a verification that the user has logged in. So this becomes tricky because we don't have access to that user information except in handle login success. Right? So basically what we have to do is we have to add this into handle login success. So we have to log in with Bob, hash his password, send that in, and then if we get a success here, this is the next thing that we have to do. All right, so this should work. Login success, and then add success callback. So now we got our user and we have a gizmo in the shopping cart, right? So this worked. But you can see how this could be a little frustrating, right? Because instead of writing your code synchronously like we're used to, user login, and then, what is it, add to cart, right? And just writing code like that, we have this abstraction that we have to deal with, dealing with these callbacks. And this leads to a really big problem that's lovingly referred to as callback hell. We're going to talk about callback hell in the next video, but the idea is in callback hell, you might have 10 items that have to occur. They're asynchronous functions that have to occur, be chained one after the other after the other. And so you basically have this pattern over and over. So this handle success function would then call another asynchronous function, and there'd be a handle success function in there, which would then call another asynchronous function. So it becomes a nightmare to kind of track and understand what's going on, whereas we're used to just reading the steps that are taking place. And that's a really nice way of doing things, right? So this level of abstraction gives us the benefit of the event loop, right? But it's problematic because the code is a little bit hard to read, but we can do it, all right? And so there have been many different ways of sort of fixing this problem, all right? And so what I want to do here is I'm just going to take what I have over here in my file and just paste it in here. I'll explain the differences. It's not much. So here I kept handle login, handle error, handle add, handle error the same. Everything's the same except we're testing the individual errors here. So we're testing things synchronously. So user login, user login, user login. So we're logging in with Bob. Finally here we get good information. And then that we're trying to do this synchronously, we're going to add a gizmo. Right? Right, so we should get bad information there, and then we'll finally add something good. So this one should work, but the problem is not logged in. Okay, so this is basically just testing everything we did before we did an asynchronous version. All right, I'm going to comment this out for now. We're almost done. So we're testing out all the various ways Bob can execute these functions. So notice add error callback. So these are the add functions. These are all the errors with add. But we did those after the fact, right? Here we tried to log in several times, and here are the login returns. They take 2 seconds instead of 1. So login error, so these are the invalids, so we're testing all of the errors, but then one of them did successfully log in. So it's the same thing we just had, except we're testing everything now. All right, and I'll just pause on this code in case you're coding along and you want to type this stuff up. It's pretty much exactly the same code that we had, except we're testing all of this now. All right, and now we want a separate system where we want the nested version, right? So our error handler here has a nested call, right? Basically chaining the asynchronous calls. So we're chaining user login inside of the success callback. We have another async function, and then potentially inside of that we would have another, chain function. And again, this leads to something called callback hell. It's very hard to kind of understand what the code is doing in that sort of system. Okay, and for this case, I added an additional user. We're gonna just grab that. It just basically copied everything from Alice. Or from Bob over to Alice, and then I have a new hash, which you would have to make sure. If your salt is different than mine, these hashes are going to be different. If your algorithm's different, all right. But we have a different user Alice, different username. All of this stuff is the same as Bob. Basically, she doesn't use dark mode, but she's got a different password. We're going to test Alice now, and she has the nested handle login success. Now we're not going to run this until 5 seconds pass, and that's so all of these Bob tests can get completed. All right, there's all the Bob tests, and there's Alice. Okay, so this was Bob logged in, and then nested login callback. So Alice was able to log in. She has nothing in her shopping cart. And then we were able to add a user successfully. Okay, so I don't know, maybe that should be like 3 seconds. But the idea here is we're just testing stuff, right? You wouldn't actually have this in a real program. So, and we've kind of combined several. You'd really want to break this code out into different pieces, right? This is obviously the memory store. This is the database side. So you would have like, a memory store file to do all the memory store stuff, and then these functions might go somewhere in that file or a different file related to the data store. So this could be the data store itself. This would be a separate file. These are our functions to interact with our data store, and then this stuff would be like our main program. So this should really be like 3 different files, right? But as I'm explaining, I just wanted to toss it all in one file, and it's a little easier to understand, but you would definitely break this up. Okay, so that's basically, in a nutshell, asynchronous callbacks. They're all over the place in JavaScript, Node.js, and the file system. For example, you open a file, there's an event that occurs when the file information has been read, and then you do something with that information synchronously. But you still have this idea of this event loop, and it's a little different in Node, but it's the same basic idea. All right, so next time we'll move on to callback hell.